Welcome class. I'm going to go over some problems related to the factoring polynomials unit in this episode of Bradford Math. So get ready. Okay. All right, so hopefully you can see the screen. It says, what is the greatest common factor of 8x and 4y? Well, when we talk about the greatest common factor, we're talking about the largest number that can divide evenly into both 8 and 40. Okay, so 8 can go into 8 one time, and it can go into 40 5 times. So that would be the greatest common factor. But neither one, the variables are x and y, so that's not a factor. So that was that problem. All right, let's do question number 2. It says, which current terms could have a greatest common factor of 5m to the second power and 5m to the second power and n to the second power? So in other words, this term here can't have that as a common factor because it doesn't have a 5 in it. This one we can actually fit. 5 goes into 5 once, m to the second power goes into m to the fourth, and n to the second power goes into n to the third. So that would work. This one here doesn't work because n to the second power can't go into n to the first. It did satisfy the 5m to the second though, but it has to satisfy all the conditions for it to be true. And then finally, 15m second n squared. It does factor in there because 5 can go into 15 3 times. M squared can go into m squared once, and n squared can go into n squared one time. So that's why that is the answer. Just trying to review some test questions for us. Okay. All right, question 3. It says a square has a perimeter of 2x plus 52 units. Which expression represents the side length of the square in units? So what I always like to do is draw a picture and kind of visualize what is happening with the problem. So I'm going to draw a square. I'm not trying to take sides here, but I'm going to square up this problem. And think about this. A square has 4 sides. So if we were to divide by 4, or we're to factor that out, well, 4 goes into 12 3 times. So it would just be 4 times 3x, which would give us 12x. And then 4 goes into 52 13 times. So if you kind of visualize that problem, each side of that square is going to be 3x plus 13 because a square has all congruent sides. So from there, we can say, well, this side plus this side plus this side plus this side, if we added all of them up, it's going to give us 12x plus 52. So that's how they arrived at that answer for the squares. All right. Number 4, it says the expression 40x to the second power minus 65x plus 50 represents the sum of the interior angles of a regular pentagon in degrees. If the interior angles of the pentagon are equal, which expression represents the measure of 2 angles? Okay, so we got an expression and the interior angles of a pentagon. So I'm going to draw another picture and kind of visualize it. So a pentagon has 5 sides. And so it means it has 1, 2, 3, 4, 5 angles. So we've got this expression, 40x squared minus 65x plus 50. Now, the first thing I want to do is I want to think about this. Well, I know that I can divide by 5 because I know that 5 is the greatest common factor because the pentagon also has 5 sides. So if I kind of factored out the 5, I would get 8x squared minus, and then 5 goes into 65 13 times, 13x squared, or x, excuse me, and then 5 goes into 50 10 times. All right, so the question I had was, when I looked at this problem, where they got the 2. Okay, well, they got the 2 because the expression with some of the interior angles, the measure of 2 angles, that's where they got that 2 from. Okay, so we have to read it carefully. 2 angles. So it will be 2 times this, because if you think about it, one of these angles is, when I divided by 5, I got 8x squared minus 13x plus 10. Where they got the 2 from is I then multiplied by 2. It's the sum of 2 angles. So kind of a tricky problem. Make sure we can see all of it there. But again, that's another problem that should help you immensely with that. All right, just trying to give a lot of examples from this unit. Okay, which term can be added to the list so that the greatest common factor of the 3 terms is 12h to the 3rd power? All right, so we're trying to find the missing term. Well, we know that this one isn't correct because 12 can't go into 6. This one could be, 12 can go into 12 once, but h to the 3rd power cannot go into h squared. Okay, we kind of think about what h to the 3rd power is. H to the 3rd power means it's like 2 to the 3rd power. Well, 2 to the 3rd power is 8, and 2 to the 2nd is 4, and 8 can't go into 4. Okay, so that one wouldn't work. The 30, 12 can't go into 30 evenly. Okay, because 12 times 2 is 24, 12 times 3 is 36. It's not going to happen. All right, 12h, just got to get my pen here. 12h to the 3rd, can it go into that? Yes, it can. It can go into that mystery term. So there we go, 48h to the 5th is our mystery term. Now, I'm actually going to factor that out. I'm going to go a little step further. So I'm going to take 12h to the 3rd, and I'm going to factor this whole thing out. So 12h to the 3rd. Well, 12 can go into 36 3 times. So I've just got a 3 for that. So if I multiplied 12h to the 3rd times 3, I would get 30h to the 3rd power. The next one, I'm going to do plus. So 12h to the 3rd, can it go into 12h to the 6th? Yes, it can. So all I need to write there is h to the 3rd. Because think about this. If I use that distributive property, 12h to the 3rd times h to the 3rd, I would get 12h to the 6th power. And finally, the last one, the mystery term, the one that we found. Well, how many times can 12 go into 48? 4 times. And I would just put h to the squared. Because if I multiplied these out, 12h to the 3rd times 4h to the 2nd, remember when you multiply exponents, you just add them. H to the 3rd times h to the 2nd is h to the 5th. 3 plus 2 is 5. And 12 times 4 is 48. So went a little bit extra there, but hopefully that was helpful to you for the factoring polynomials. And we will do one more for this video. Maybe we'll end up with another music entourage at the end. Hopefully you liked my introduction. It was A Careless Whisper by George Michael, if you want to download it on iTunes. Anyway, it says which expression is equivalent, and you can see the expression 7a squared b plus 10a squared b plus 14a squared b to the 3rd. Well, what did they do? Think about this. What was the greatest common factor of all that? Well, all of them, well, let's look at the coefficients first. We have 7, 10, and 14. They don't have a common factor. It's not working out for them, okay? they don't have a number that can divide into all of them. So we're going to move on to A. Well, this one's got an A squared. This one's got an A squared. This one's got an A squared. So guess what? A squared is a common factor. All right, let's look at the B's. I want to see what all the buzz is about. So this one's got a B, this one's got a B squared, and this one's got a B to the third. So the only really common one they have is B. And that's why they factored that out. And you can see when they use the distributive property, if they say A squared B times 7, they get this first term. If they say A squared B times 10B, they get this term. And if they finally multiply this times this, they would get this term. So that's what we mean by factoring. Hopefully you enjoyed the music video, or, oh, not the music video, the educational video. I'm not going to produce music videos. I'm not yet at that talent level. But that's another episode of Bradford Math. Hope you enjoyed it. We'll see you later.